questions that I want to focus on during this brief presentation. And
Can't hear you.
Can't hear you. You can't hear me now? Alright, so I got to know that microphone is directional, so I tried to find out the microphone, how and everything, but excuse me if it doesn't come out always right. So I have 3 points. I didn't know what Professor Wallace is going to say about the IPCC reports, and you already heard that there are some uncertainties associated with those model predictions. But in addition to that, I would say that the information that is contained in those reports is not always particularly useful for the local and regional decision making, and this is the point that Dr. Margaret Kolk already made. So the point of this presentation is actually to identify some of the gaps of the information that we need at the local and regional level in order to be able to design, devise adaptation and mitigation policies. And finally, I'm new here, I just came in August, but also climate change is new to the urban and regional planning, so we're going to try to identify where should our priorities be in our research, especially in urban and regional planning, in order to respond to those challenges that are ahead of us, particularly in those vulnerable areas and vulnerable sectors in South Florida. So I don't want to take this. So some of the problems that are associated with having this information at the global level is that those research projects have been designed for different purposes. Some of those purposes are, for example, to understand, to improve our scientific understanding of what climate change is about, and we already heard a lot about this. Also to identify some specific targets of mitigation, and also to be able to identify areas and sectors that are particularly vulnerable to climate change. And last but not least, also to develop adaptation strategies. And each of these different purposes has specific information needs and does require a targeted approach to provide this information. I'm not going to spend much time on that, talking about the IPCC reports and why they're not particularly useful to planners. My point here is just to move the projections that we have at the global level and the projections that we see from the scientific perspective and those that go into the international conventions. We need to bring this down to the national level, developing adaptation policy frameworks, and also bring down to policies such as the national adaptation programs of action. And finally, and which is the really important part of all that, and this is where I hope we're going to focus on research effort, is to bring this to the local and the regional level and see how it's going to affect our communities. So the takeaway point of this introduction to this point is to actually that we make sure that we provide our decision makers with specific types of information so that they can, in order to design and implement those policies. Very briefly, I'm going to talk about the adaptation strategies and some of the things that have already been done actually in the Pacific, some of the Pacific islands, Thailand, India, Japan especially. So we have some benchmarks where to look at when we start devising our policies. So the information that we need at the local level is this type of information how we're going to change land use, what we're going to need to know about how climate change is going to affect infrastructure, water supplies, less subsidence where it occurs. It does not occur here in South Florida, but we have heard from Professor Wallace that we have such problems in Texas. Also, beach erosion accretion as a result of shoreline retreat, as a result of sea level rise, storm surges and flooding. Saltwater intrusion is a big problem that is going to affect our water supplies. Changes in tidal heights, we already, and also the basic needs and the food security of the population and the communities that live. Those are some of the things that I'm going to be talking here have already been observed in other parts of the world. For example, there is a possibility in low-lying and poorly drained areas, and South Florida is one of those areas, where there is a possibility that those areas that were not originally suited for human development, it is possible that the land will revert to swampy conditions as a result of sea level rise. Also, as we already heard that those low-lying areas are particularly vulnerable to the impacts of extreme climatic events such as flooding, storm surges, and also they're very susceptible to even slight changes in natural conditions. As far as coastal infrastructure is concerned, some of the predicted impacts indicate that there will be a reduction in the functioning and safety of all kinds of infrastructure, including harbors and fishing ports, artificial islands, reclaimed lands, disaster prevention facilities for tidal surges, waterworks and power generating facilities, drainage and sewage system, and coastal protection facilities. Also, a rise in sea level may weaken the ground's capacity to support wind and thus increase the susceptibility to liquefaction. And this is going to affect all the infrastructure that we have built upon on this areas. Some other predicted impacts include saltwater intrusion. I know that South Florida Water Management District does a lot of research on that. I read one study that predicts how much we need to raise the water in the canals in order to prevent saltwater intrusion. And if you add this to the sea level rise, well, you see that the picture gets really daunting. Also, as I said, there is a significant analysis that's going on about the shoreline retreats as a result of sea level rise. Also, tidal ranges and increasing the heights of waves. Those are some of the other impacts. And also the big question is how much it's going to cost in order to do whatever we need to do, retreat where we have to retreat, accommodate sea level rises where we can, and finally protect our assets. And one study that's been done in Japan shows that it's probably, for example, for a small country, Japan, it's going to be around 11.5 trillion Japanese yen to build those protection and sustain those protection measures. When we have a sea level rise of 1 meter, so we need to also. Those are some of the so-called studied sea level rise predictions. Probably the earliest one was done by the National. This is just one of those different types of studies. As Professor Wong has already talked about the IPCC predictions. The point that I want to make here is the point that he already made also, that the static rise predictions are problematic, very accessible. The static rise predictions are increasingly large over time with respect to historically observed rates, but also, as Professor Wong has said, the sea level rise has not occurred in a linear manner. It's had like little chunks over time, and even it can go down. Also, another point is that sea level rise is not expected to occur uniformly throughout the globe. And I have my next slide shows how it occurs in different parts of Florida. Also, and this is due the fact that there are regional differences due to surface temperatures and vertical mixing, changes in the tidal action and storm surges. And what we need is probably that's already something that's already been done by Professor Wallace and the researchers at the University of Miami and some other university here in Florida. We really need original, specific, continuous function graphic rise predictions where with uncertainty analysis, if it's possible. Of all those static rise prediction, the only one that I think that has an uncertainty analysis is the one published by EPA. So maybe I'm not right, maybe I don't have the full information on that. So this is the relative sea level rise along the coastline of Florida. You see it ranges between 11.5 inches per century in St. Petersburg to 5.5 COT with the relative, the average sea level rise is about 89 inches per century.
That was the last century.
It was, I think it's calculated over 100 years.
That's the past century, right?
No, that's not the coming.
No, that's the last century. Yeah, that's, I mean, I'm sorry, the past, those are the observed relative sea rise. So, I want to make this point. So those are the observed ones, so it's not predicted. There are two fundamental response options to the risks that are posed by anthropogenically induced climate change, and those are the mitigation of climate change and adaptation to climate change. When we talk about mitigation, we actually are talking about taking control over the greenhouse gas emissions and also enhancing the things that can sequestrate the carbon dioxide. The second part of it is adaptation, and which is relatively less developed. Actually, there was one study that was just published recently by Wheeler, who examined all the plans that we have at the state level and also at the city or the county level about climate change. And all of them, almost 100% of them, they focus on mitigation efforts, so how to reduce the greenhouse gas emission, which is very important, but for some other areas, it probably it's not, adaptation is not, strategies are not that important for other parts of the United States as they're important here in Florida. I'm going to skip this a while, we need to turn our attention. I just want to draw because to those measure the different type of adaptation strategies and what we need to do. And when we do research here at the School of Urban and Regional Climates, we need to take this into consideration. So the climate need puts the emphasis on progressive abandonment of land areas and structures in highly vulnerable areas, which means non-development in susceptible areas, means conditional phase-out development, withdrawal of government subsidies, and resettlement. Accommodation is another strategy where the emphasis is put on the continued use of vulnerable areas, ecosystem conservation, and adaptive management. In order to accommodate, for example, sea level rise, we need advanced planning to avoid the worst impacts. We need to modify the land use plans that we have today. We need to protect the predator ecosystem. We have to have specific regulations in hazard zones and hazard insurance to reinforce regulation. And finally, protection refers to how to defend those vulnerable areas and sectors. And we talk about hard and soft structural measures, and they include dikes, levees, and flood walls, sea walls, groins, starch breakwaters, and soft structural measures include periodic beach nourishment, bill restoration, and creation, and secondary forested recall, even at the beach grass that can keep prevent to a certain extent the beach erosion. So those are the things that we need to look at. We discussed this with Dr. Voss, and he said that they started doing this in the Netherlands maybe 20 years ago, and they just finished those seawalls. So we need to plan on how we're going to do that. And so we're going to, we're working, this will probably be the first of a number of studies that we're going to do. This is what Andrew and Dr. Voss were working on. We need to get data based on previous studies on the relative sea level rise rates and then conduct root damage analysis. We're going to use the LIDAR data, light detection and ranging data from the Laboratory for Coastal Research at Florida International University, and probably we're going to have the same maps of Broward County coastline like the one that Professor Walnut has for Miami-Dade County. We're going to look at advanced appraisals, parcel data. What I want to do is calculate the centuries of each parcel and then look at the topography using the LIDAR data and see how much of those